Right, so I have no idea what the acoustic is like. Can you hear me on the back? Yeah. Perfect. So, well, I'm Ricardo, as that says. That's my email address, and my Twitter handle is going to be at the bottom if you want to get in touch. So let's get this show on the road. Basically, this talk is going to be about the thought process that goes at least through our minds, or at least my mind, and going to be using our ROBL, that's the royal we thing, when evaluating a language. So, for instance, the part of the thought process that I had when I realized that I had effectively committed to teaching Clojure in like 20 minutes was like, what the hell am I doing here? So let's get the show on the road. This is going to be by necessity both brief and incomplete. But quick show of hands, first of all. Get an idea about everyone. Who here is not using Clojure or has actually just started using it? Yeah, sure. Now, who's started using it was kind of just finding their way around the language? Okay, that's better. And who's like feels fully comfortable with the language right now? Okay, a lot of you are not going to find a lot in here than we have, because this is for the first two groups. This is mostly geared towards beginners and talking about exactly how there are a lot of misconceptions that go into when you're encountering the language in the first place. And I found personally that usually when picking up any programming language, and I've picked quite a few over the years, I go to 3 stages. The first one is that you learn by reading. You learn by reading someone else's work. Then you learn by copying when you just go in and are aping someone else's code and changing small things. And finally, you learn by creating. You learn when you're actually building your own things. And with Clojure, I actually went really quickly through the first 2 stages, which wasn't entirely surprising to me because I had worked with other functional programming languages before, and Clojure wasn't my first list. It was just the first list where I happened to put something in production. It wasn't until later that I realized that I had actually kind of screwed up the first 2 stages, at the very least the reading part, because, and the reason why I screwed this up was kind of strange. I realized after a while that Clojure was hard to read for me because of how simple it was. After a while, I realized that I was superimposing into Clojure the more complicated constructs of languages, of other languages that I had gotten used to in the last 10, 15 years. And we know, after you have dealt with languages for a while, after you have been programming for a while, like you have, you sort of take syntax for granted. It is that unchangeable part of the language, the incantations that you need to recite in the proper order or the compiler paths, right? So for instance, if I were to show you this, I probably don't even need to tell you if this is a C# or Java or C++ or whatever, or any other C-like language. Your eyes will immediately go to the markers, for instance. So let's describe how we see this in the first place. If you're looking at this, you're going to very quickly sweep by the public static access definition, and then you get like, okay, here's the type. You get the +1. At the moment that your eyes hit the parentheses, you're going to go like, okay, fine, we're declaring a function or a method, and we have basically the parameters wrapped in parentheses, right? And given that we know that this is what we're looking, we know that we have a code block which is wrapped in curly braces in this case. And the thing is, we really have no way to do this other than doing descriptively. And at least our brain has no other way to process it other than go down to the token and process it this way, because all these markers have no real usefulness other than to be syntax markers in and of themselves. And in some contexts may actually mean different things. Like the curly braces here is just for a code block, but in C# that can also be used for a tuple, or it can be used for a dictionary initializer, for instance. And if I were to show you, if you're not familiar with Clojure, and I were to show you the Clojure equivalent, your brain is probably going to go in the same direction. And the brain goes and says like, okay, fine, we don't have all the accessors, but we have defn, that means we're doing a function. Perfect. And I guess since this is a list, we wrapped everything in parentheses, so the function we wrapped in parentheses, right? And this guy be the parameters, because we're we're using them later. So we have the parameters wrapped in brackets because I guess we got parameters in parentheses. But then there's the body of the function, which we once again wrapped in parentheses because reasons, right? So looking at this, going down to the token is actually about the wrong way of thinking about Clojure, even though it is the way that other languages sort of conditions to look at looking at this. For instance, one of the first questions that I asked myself way back when was, if I have a function that has multiple lines, do I wrap every line in parentheses, or do I need to wrap the whole thing in parentheses as well? And this whole thinking about what to wrap how was exactly what was gripping me. So let's dissect things a bit. And I'm actually going to go back to fundamentals here, and this might be again obvious for those of you who are right now familiar with Clojure, but for those of you who are just finding your way right now or getting started, just even if this seems obvious, just give it a bit and actually get it in. So this is a list, obviously. This is a vector. We can go about how they're different later if we have time. Basically, the list acts as you would expect a list to act, where it's easier to add things at the start, and the vector it's easier to add things at the end because they're linear arrangement. Everything cool? Okay. This is also a list, and this is also a vector. It doesn't matter that we have a function in there, that's a perfectly valid vector in Clojure. Now, everyone cool with this? Great, because this is effectively 90% of what you need to know in order to properly read Clojure code. So, even though we have that, let's talk about evaluation semantics a bit. Suppose that we have these two lists. Both are perfectly valid lists, and if you're just starting with Clojure, it obviously is a list, then the question would be, why does the first list ends up on a function invocation and the other one doesn't? Anyone? Okay. It's actually not the case. It's a trick question. How Clojure evaluation works is that it will always assume that the first element in a list is something to invoke. On the first list, it's going to invoke the function of plus in this case, and it assumes that the rest, anything that comes after the first element, are parameters. On the second case, it's going to assume, oh, they want to execute an integer, then it's going to do parse because it can actually invoke an integer. Now, there's a way to avoid this, which is called quoting, but we're not going to get into that right now. Quoting effectively means take this list literally instead of trying to invoke whatever comes first. Now, if you're joining us from Java or C# or Ruby or any other language that is not a list, there's probably a perfectly natural reaction to this, and your brain is going like, yeah, how am I doing this? Everything's a list, we get it, it's all data structures. Now, that voice is probably also saying, except all the sort of cases that are actual syntax are not actually lists, right? Like if we have an if, or we have a loop, or if we need to declare a function. These things are going to have a syntax that probably kind of smells like this, but it's not exactly the same. And that is actually one of the things that people keep asking me when I'm getting them introduced to Clojure, like, but ifs are different, right? Like, or the function declaration is different. So let's look at if, for instance. This already is it's already looking kind of different than before. You know, we have the all is by itself, it's not wrapped in parentheses or anything. And then we have the two branches that we would expect for the if, right? If true or if false. And these branches are wrapped in parentheses, but why? And then there's this question mark in here that why is the question mark in here? Is the syntax at all? And in fact, if you have read about Clojure, you may have heard there's this thing called special forms. And an if, in fact, is a special form. So let's talk a bit about special forms. One here is with the expression special forms. And one thing is, this is the stuff that's different, right? Because it's special. And in fact, when I say special form during this presentation, or when you hear special form in the future, you shouldn't think of special form as a special case. What you should think about special forms, when you hear special forms, is that they're primitives. These are things that behave the exact same way, they're just directly implemented into the language. But primitives in Clojure are so rare that we call them special because everything else is like in Clojure code. So if we go back to the coding video, we have this thing, right? Remember that I just said that everything in Clojure, the first element is whatever we're going to invoke, and the rest are the parentheses. So what we have here is that we're invoking a special form called if, and all these other things, the odd, to do something else, all of these other things are parentheses as well. Parameters as well. The odd, in fact, this question mark is not even syntax, it's just a convention to indicate that something is a Boolean. And these things here, they are not branches, they are also parameters. And the first parameter is whatever we're going to evaluate if the other expression is true or truish value. And the second is whatever we're going to evaluate if this is false. This whole thinking of branches in parentheses, thinking of things in terms of the traditional languages that I was introduced to, was precisely what was stripping me. In fact, as I mentioned, we're evaluating whatever the parameters are. So, as in this example, you can see that you don't even need to have anything wrapped in parentheses. On the first case here, if, for instance, get list is true, we're going to evaluate the result of calling convert to string with the list with the vector actually that we're passing. And if we actually did not get a list, we're just going to return a string. And we can just have this thing because a string automatically evaluates to itself, so there's no particular reason to actually have this wrapped in any order. And this is, I find, the key thing about Clojure. You need to stop thinking in terms of execution. I look at the evidence thing and I thought originally, well, if this thing is true, then this thing gets executed. Otherwise, the other thing gets executed. So, of course, having a freestanding string in there didn't make any sense for me because a string is not something you execute at all. What you need to get used to is the idea of evaluation. Every form in Clojure will evaluate the last item and then return it. So let's look back again at the function declaration that we had at the start. Right. As I mentioned, this looks like its own thing. If we could just think that we have the parameter identifiers wrapped in brackets and then the function bracket. And this is actually not how we should be reading this. As I mentioned earlier, this here is not syntax. This is nothing but a vector. What we have here, if we format it a bit different so that we can see the hierarchy of things, is the define, which is what we are evaluating here. And then all these sort of things after the define are parameters that we're passing to it. The first parameter is going to be an identifier that we are going to bind the function to. The second identifier, the second parameter in this case, is a vector with parameters, not something in brackets. This is an actual data structure that anything else could grab and manipulate. And after this, the parameters the final set of parameters is a list of forms to evaluate, and the result of the define is the last item that is evaluated. Is this absolutely clear to everyone before we move forward? Or any questions? Cool, because we're short of time. So, how about if we get something more complicated like that? The beautiful thing about Clojure is that since everything follows the exact same syntax and the exact same evaluation semantics, even unfamiliar Clojure code becomes at least understandable once you separate it on that hierarchy of the list. For instance, we already know that this is a define that we're invoking, and we can just look at its parameters in this way. That string is the identifier, then there's the vector for the parameter identifiers that it receives, and then there's a list. This list starts with something called a let. Now, we don't know what let is. We have no idea at this point, we haven't looked it up, but we know that let is something that we're invoking And we know that let is followed by parameters in this case. A vector with some stuff in it that somehow it's going to use, and then another form that is evaluated. Remember that I said that every form in Clojure returns the last value evaluated. So in this case, even without knowing what let does or what cleanup parse does, we know that the let form is going to return the value of cleanup parse, and we know that the defn is going to return the last value, it's going to resolve on the last value of the let. And the thing is, everything that you find in Clojure, every little bit of code that you run into, is going to follow the exact same pattern. So this truly is the tower of Clojure for me. As far as evaluation goes, there is absolutely nothing but this. So with that in mind, let's break some stuff. Because I'm going to be abusing the syntax a bit here for some examples, just because as this guy called Doug Stanhope says in a stand-up bit called system moderation, you can't know where the middle of the road is unless you have seen the file curve. So, first of all, is this valid Clojure? Anyone thinks this isn't valid Clojure? Okay. This is actually syntactic valid Clojure. It's not semantically valid because inc expects one parameter and the parameter cannot be, is supposed to be a number, it cannot be another function. So that's not var and nothing, but this is actually valid Clojure code. Now, how about this case? If you were to encounter this in the middle of a Clojure program, would you expect this? Would anybody expect this to be valid Clojure or not valid Clojure? Show of hands. Anyone thinks this is invalid? It's actually not. Because every of those things evaluates to something. The freestanding unique identifier, for instance, evaluates to a pointer to the function itself. The second one is a vector, which contains the function. The third one is a vector, which contains the function and a number. And the other one, of course, is a vector with more things. How about this? Is this syntactically valid Clojure code? I mean, there's hardly any parentheses in there. So. Show of hands, does anybody think that this thing compiles? Doesn't. Doesn't compile. Who says it doesn't compile? Okay, now, for those of you who does think that it compiles, do you think that this will run? Like, does anybody think that this doesn't run? It actually does as well. And this is, in fact, if you think about it, if you separate it a bit, this is what this is. If you separate it on its basic elements, this is what Clojure will do when evaluating this, is that it's going to go down the forms one by one, evaluating them, and return the last value. So the first element will be a vector, which evaluates to itself. Nobody uses the value, so we throw it away. The second element is an evaluation of a function, but again, nobody uses the result value, so we throw it away as well. Then we have +1, which is a link to a function. Fine, we evaluate it, nobody's using it. Then we have a couple vectors, and then at the end, we just return the same value that we receive as a parameter. So this is effectively just a very noisy identity function. Now, this is, of course, just me abusing the syntax to hopefully disabuse you of some preconceptions. I hope you're never going to encounter any code like that. It's just an example of things that might confuse people as what happened, why am I encountering a freestanding function identifier in the middle of the code? Why is there a plus in the middle of a vector? And these two preconceptions are that, as I mentioned, first, that everything needs to be wrapped in parentheses. And that second, there might be all these syntax special cases. In fact, as I mentioned, every bit of code, Clojure code that you encounter, even the ones that might look weird, follow this exact same evaluation semantics. First case, we're applying a function, and the function is just one of the parameters that apply receives. On the second case, this is also a bit tricky, but what you have there in the middle is a hash map. The first item is an identifier, the second item is always the value. So in this case, we have a hash map where the keys are functions, and we're just assigning an integer to it, for no good reason more than to show that this thing would be possible. Now, we have about 30 seconds left, so we're running out of time, and this was extremely tightly. time, it seems. So, thank you, and any questions in the last 30 seconds? No? Okay.